Hello, welcome back. I have no credentials, I'm just a student, and today we're going through 7.3 and 7.4 in the Math AASL course. I put these two videos together as well because these chapters are very short. And after this, I probably won't do math for a bit. After this, I'll probably either start with business management or psychology. I just realized I forgot to say my name. My name is Johanna, and fun fact, I had to film this twice because I filmed the entire thing and then looked at my iPad and was like, oh, I didn't press play. But yeah, let's just get into it. So chapter 7.3 is the line of best fit. The book defines the line of best fit as a straight line that is drawn through the center of the graph of data points plotted on a scatter diagram that lies close to as many points as possible. So in chapter 7.4, we'll get in how to do this with the calculator and using actual, maths. But when you do it by eye, it's important to try and get the same amount of points on both sides and also to include the mean points. So this would be the x, the mean of the x, and the mean of the y. To do this, you would take your data, add them all up, and then divide them by the amount there is, and for x. And then do the same thing for y, and then that is the point that this line of best fit must connect to. So that has to be a part of your line. In this example, both of the mean values are 6.6. So when drawing in a graph, you would do this. This example is a little bit stupid because it's basically a straight line, but I mean, it's not a straight line, but it's very close. But let's say that the points were more spread, you would try and get the same amount of points on both sides of the line and connect to the mean points. The last thing you have to know in chapter 7.3 is interpolation and extrapolation. So these are the two different predictions you can make using the line of best fit. So interpolation means inside your data. Extrapolation means outside your data, so extra data. You can think inside, extra, ex. So that's like how you would remember that. So if the correlation is very strong, then your interpolation predictions will be likely very accurate. If you go very far outside of the domain, your extrapolation data might be very inaccurate because let's take, for instance, height. With height, if all your data is of people that are very young, their height will be rapidly changing. But if you took data from people who are older, then it's going to slow down or completely stop, which means that if you were to guess using the line of best fit, like, oh, what would y be when x is 35? If we say x is years and y is height, then you would most likely get a very inaccurate answer. That is everything for 7.3, line of best fit. Now we'll get into Math AASL 7.4. Chapter 7.4 is the least squares regression. So when it comes to this is essentially a way of finding the line of best fit using an actual calculator and getting a more accurate result than just doing it by eye. So what you need to know is you can improve your line of best fit by using residuals. So residuals is the vertical distance between a data point and the graph of the line of regression. You are trying to find the least squares regression line, which is the line that has the smallest possible value for the sum of the squares of the residuals. Essentially, what this means is just the most accurate line of best fit or trend line. So the formula for this is y equals a times x plus b. You can use any letters to denote this, but in this sense, In this case, B stands for the value of y when x equals 0, and A is the rate of change. Of course, this is different depending on what calculator you have, but for my calculator, you go into Stat, then Edit, then Stat, and then you move to the Calc part, and then press LINREG, and that will give you the values of both A and B. So choosing your line of regression. So essentially there could be two different lines of regression. If you're trying to find the value of y, then you would use the line of regression that is y equals a plus bx. And if you want to find an x value, you would use x equals c plus dy. For the line for the finding an x value, the c is the value of x when y is 0, and the d is the rate of change. These two lines of regression may be exactly the same. How you would check that is if the r value is the same, whether you plug in the x or the y first, then the line of regression is the same as well. Since that concept might be confusing, I will just say right now that if you have a perfect correlation between your x and your y, then both of the lines of regression are exactly the same. That is essentially what that means. The last thing you have to know in 7.4 is about piecewise linear functions. These are functions that are not as easy as you can represent them with a single linear function, but something changes where you would need two linear functions or more. So here's an example. I made up a really stupid real life example, and just to be clear, it is a real life example, but the numbers do not correlate with the actual real life situation. I'm not really sure how the real life situation would work. So I'm thinking a chips bag where x would be the speed at which you're eating the chips, and y would be, or f of x, would be calories. That might be really weird. So I put x times 50 if the number is 40 or below, and 70 times x if it's above 40, and essentially you would just draw two lines. Now it is time for the quiz. So the first question is find the line of regression, or find the equation of the line of regression. And the second question is to predict what would happen if x were equal to 10. Feel free to pause and come back when you have your answers. Now it is time for the answers. So I forgot to put a question mark in, so I just did that. The equation of the line of regression is y equals 0.49x plus 1.13. And then I just proceeded to use that to find the y when x equals 10, which was 6.03. Now we are done with all of chapter 7. Yay! So good job! So thank you for watching. Hopefully you learned something. Feel free to subscribe, like, and comment. Follow me at Johanna Frennert on Instagram if you feel like it. And goodbye!